Right, this video is going to look specifically at domain restrictions, including vertical asymptotes and removable discontinuities when we have a rational function. So I have the parent reciprocal function here with some arrow notation of what's going on. Notice as x goes to 0 from both the left and the right, the graph never crosses. So it gets really, really close to the y-axis, but it never touches it. In that case, we're going to call it a vertical asymptote, and we say the line x equals 0 is that vertical asymptote. So by definition, if you have a vertical line, x equals some number a, where the graph goes really quickly to positive or negative infinity from either the left or the right, here's the arrow notation, and we call that a vertical asymptote. So in a rational function, which is the division of two polynomials, we know that the denominator cannot be 0. That's going to be our key indicator of where to start looking for vertical asymptotes. However, you have to make sure that these discontinuities are not what we call a removable discontinuity first. A removable discontinuity happens at an x value if it is a common factor in the numerator and the denominator. So we need to do that first, and then anything left over in the denominator will be a vertical asymptote. Let's look at an example. Find all vertical asymptotes and removable discontinuities of this graph. So I notice that I have the factor x minus 2 in the top, and I have a difference of squares x squared minus 4 in the denominator. I'm going to factor x squared minus 4 into the difference x minus 2 and the sum x plus 2, or into its conjugate pairs. Notice that I have a common factor in the numerator and the denominator. Therefore, I have a removable discontinuity when x minus 2 equals 0, or at x equals 2. From there, the graph is going to behave just like the function 1 over x plus 2. I'm going to have a vertical asymptote whenever the denominator is equal to 0 after you get rid of any like terms in the top and the bottom. So I have a vertical asymptote at -2. If you wanted to sketch a graph of this, I know it doesn't have us do that, but this is the parent function moved to the left 2. Everything from negative infinity to -2 is going to be the same. Notice that vertical asymptote at x equals -2. However, when I have x equals 2, if you were to graph this with a graphing utility and try to find x equals 2, you would find that there is a domain restriction right there. There's a removable discontinuity at x equals 2.